Hello everyone, so this year's episode is brought to you by the rather mundane looking chemical here, sodium chlorites. Chlorites are kind of the often forgotten member of the chlorine and oxygen kind of family, if you will. But we all know perchlorates, chlorates and hypochlorites, but in between there is chlorites. It's easy to assume that the more oxygens you put into a molecule, the more unstable it gets, but in this case, it actually stabilizes the molecule through resonance because there's only one negative charge on it. Just ignore that. Hypochlorite, because it's so unstable, is actually the best oxidizer out of all of them, and perchlorate is the least powerful oxidizer. However, it does contain the most oxygen atoms, which is advantageous if you want to create gaseous products or actually oxidize something, because you have more oxygen atoms there to actually oxidize things with. Because of its high oxygen content and its stability, perchlorate is often used in commercial flash powders and rockets and fireworks and that sort of thing. And we can see in this mix, it actually took quite a lot of effort to light, and it burns with quite a bright flame, so it releases quite a lot of energy. That's a lot of smoke. I should not have done that inside. Chlorites are more popular in an amateur setting because they're actually really easy to make. However, they're quite unstable and lead to quite violent mixes with chemicals, and some are very unstable, especially with sulfur. Finally, we get to sodium chlorite. Now, sodium chlorite is never used in flash powder mixes, a little bit because it forms a sort of solid equilibrium with sodium chloride and is only stable at an 80% solid concentration, and also because it really likes to just burst into flames and be very unstable, which is not what you want in a flash powder mix. That was quick. Because chlorite is such an unstable anion, I thought I could take heavy metals like lead and silver and make explosive salts of the chlorite anion. Lead chloride is a beautiful yellow solid that is very sensitive but doesn't really have much power, and I contribute this to the fact that it really doesn't generate that many gases. You've got a little bit of lead chloride or lead oxide, maybe metallic lead, and there's not really many gases left over to actually produce a kick from the molecule. So it really just likes to fall apart and be pathetic. I feel you though, lead chloride. Same with the silver one, but even more so, and I think that's a problem also because it's really hard to remove all the silver chloride from it because of the chloride sort of equilibrium, and the chloride likes to decompose into chloride, and silver chloride is so insoluble that it sort of precipitates out first, so you just end up with this shitty product that is just shitty. Yeah, I understand. Yeah, it was a bit of a disappointment, but can't win them all. The real interesting thing with chlorites is that on acidification they release a gas called chlorine dioxide. This gas is used industrially for things like bleaching wood to make paper and curing autism. It's easy to tell from chlorine because it's more... Hang on, wait. Curing autism? What? Hey, sorry, my script says that chlorine dioxide can cure autism.
Yes, Tom, it is called Miracle Mineral Solution, and it not only cures autism but also every cancer, AIDS, malaria and acne.
Wow, that sounds toxic and dangerous.
You take a 28% solution of chlorine dioxide and then you drink it, and it kills all the bad things like the autism virus.
That's amazing. Does it actually work?
No.
So you're basically giving bleach to kids for no other benefit than to just poison them?
Yes.
Wow, that sounds fucked up.
It is fucked up.
Alright, I'm kind of sorry I put you through that, but yeah, if you are a fan of MMS, fight me. I'm not a tough guy. Anyway, back on track. Chlorine dioxide is a banana yellow gas, which looks really strange and smells even worse than bananas. Well, obviously. But it smells like chlorine, but sort of more clinical. Smells are hard to describe, just go with it. One of the reasons chlorine dioxide is so dangerous as a gas is because it has no upper explosion limit. Now, when you think about things like hydrogen, you think, oh, that's explosive. Acetylene, that's sort of explosive as well. But they need to be mixed with air and oxygen to a certain extent. So if you have a jar with 100% acetylene, you can't blow that up. You can't light that on fire because there's no oxygen for it to, react with. And the same with hydrogen. Chlorine dioxide is just detonating under its own weakness of bonds, right? So it's turning into chlorine and oxygen. So if you had a jar of 100% chlorine dioxide, it definitely will just destroy the jar. So there's no upper explosive limit. And this isn't a thing that's all that common really, a gas that's just an explosive on its own. Because of chlorine dioxide's instability, I set up some fuses to some steel wool, and when we set off the steel wool, we can see the gas actually detonates inside the tube, which is very exciting, but okay, no, it's actually not that exciting. We should probably scale this up an immense amount. This is dangerous because chlorine dioxide has been said to have quite a high UV sensitivity, meaning I'm doing this in broad daylight, and UV light has been known to detonate chlorine dioxide. So there was a high chance it could just all blow up as soon as I added the acids to the chlorite. Anyway, I set it all up, ran all my fuses out, and tried to set it off.
Go off, you mongrel.
And once again, another engineering win for me. My electrical system just failed on me. But then I started thinking, wow, this is a bottle full of chlorine dioxide in broad sunlight. Maybe I should not approach this bottle, which is probably a good bit of advice.
Whoa! Fuck me. Holy fuck. Yeah, it's definitely shrunk. It's got very, very hot, but I didn't see any flames at all. I think it's just the pure heat of that reaction has really, really shrunk that bottle.
Anyway, that was intentionally dangerous, so let's do it again. This time I made sure to set up my electrical system correctly, and of course that meant it failed once again. So I had to just wait and let the sunlight do its work.
Fuck!
Alright, I think it's enough unexpected detonations for one video, so thanks for your support, and I'll see you next time. I actually do have some things planned. Just got to actually find time to do them or something. Fucking yay. Fucking yay.